Hello, everyone. My name is John Lewis, and I'm joined today with Caroline Lee. We are program managers on the Cloud and AI Engineering Customer Experience team, and today we're going to be discussing Microsoft's CASB solution, Cloud App Security. Cloud has changed how we secure our environments. We no longer have a data center where all our apps and services are located. We've extended those into the cloud. This means users can access those resources from any location and on any device. Moving to the cloud increases flexibility for employees and IT alike. However, it also introduces new challenges and complexities for keeping your organization secure. To get the full benefit of cloud apps and services, an IT team must find the right balance of supporting access while maintaining control to protect critical data. Microsoft's Cloud App Security is a cloud access security broker that supports various deployment modes, including log collection for shadow IT discovery or applications unsanctioned by your organization, API connectors for visibility and governance of your sanctioned applications, and it provides sophisticated analytics to identify and combat cyber threats across all your Microsoft and third-party cloud services. Microsoft Cloud App Security natively integrates with the leading Microsoft solutions and is designed with security professionals in mind. Some of those integrations include Azure Security Center for cloud security posture management, Azure Information Protection for classifying and encrypting documents, and Microsoft Defender ATP to enrich the data stream and provide a mechanism to secure and block applications. When IT admins are asked how many cloud apps they think their employees use, on average they say 30 or 40, when in reality, the average is well over 1,000 separate applications being used by employees in your organization today. Cloud Discovery helps you know and identify which apps are being used and what your risk levels are. 80% of employees use non-sanctioned applications that no one has reviewed and may not be compliant with your security and compliance policies. And because your employees are able to access those resources and apps from outside your corporate network, it's no longer enough to have rules and policies on your firewall. So phase one is to discover and identify shadow IT. This can be done through the following methods. First, natively integrating with Defender ATP provides a quick and easy way to immediately start collecting data on cloud traffic across Windows 10 devices on and off your network. For coverage on all devices connected to your network, it's important to deploy the Cloud App Security Log Collector to collect firewall and proxy data. Please note that some third-party proxies, including Zscaler, have native integrations and do not require the installation of a log collector. Once data is ingested to Cloud App Security, it's time to identify the risk levels of your apps. This is achievable with Cloud App Security's risk catalog, which includes over 16,000 applications that are assessed using over 70 risk factors. Those risk factors include general information about the application, such as the app's publisher, and through security measures and controls, such as support for encryption at rest. Phase 2 is all about evaluating and analyzing that data. Using risk factors, you can check the compliance of the application to ensure those apps meet your organization's standards, such as HIPAA and GDPR compliance. Now that you know whether or not you want the app to be used in your organization, you'll want to investigate how and who is using it. We can easily understand the usage patterns and identify high-risk volume users. With that information now in hand, we can make an informed decision. Phase 3 allows us to tag those apps to classify them according to its business status and justification. These tags can be used for specific monitoring purposes, or they can be leveraged to prevent users from accessing those cloud applications. In order to ensure continuous monitoring, we can define policies that monitor the apps and provide controls where needed. Let's pop into a demo and take a look at a few use cases. First, let's navigate to Discover and select the Cloud Discovery dashboard. The dashboard shows us the applications which have been discovered from your firewalls, proxies, or Defender ATP integration. We can review the total number of apps, IPs, users, and traffic broken into upload and download. We can quickly filter the report to gain additional views into the data associated with the discovery, such as users associated with an app category and apps considered unsanctioned. This dashboard also shows all the discovered apps, the top users, and risk levels for each application. Now, let's pivot to the applications which have been discovered and matched to our application catalog. My environment has over 302 applications and provided a risk score for each app. If we need to filter further, we can apply basic or advanced filtering here. I will go ahead and display apps with a risk score of 6, as well as filter to a specific application that I'm interested in. I've now trimmed the list to just a single app, and I want to take a closer look at the total traffic, the users, and IPs. In addition, I may want to tag this application. We could tag it as review, we can unsanction it, or update the app score from the ellipsis on the right-hand side. But first, I need to make an informed decision based on the risk indicators outlined for each discovered app. Here you can see general information about the app, such as the consumer popularity, the security posture, and whether or not there is support for an admin audit log, the compliance of the app to see if it meets HIPAA regulations, as well as any legal requirements, such as GDPR. If I need to understand which users are actually using this app, I can navigate to reveal those users. I can sort by the total traffic, the upload, or transactions. Here I'm just going to sort by traffic, and I can see all the IP addresses which have accessed this application. I can follow the trail to see which apps and users are associated. So let's click into this IP and look at the 8 discovered apps for this IP. I can also get a quick view of the user history associated with that IP address. And now that I have the information that I need, I can unsanction this application. And by doing so, with integrations with iBoss, Zscaler, and Defender ATP, we can automatically block that application. In addition, we can click the ellipsis in the top right, and we can export a firewall script. We have many of the most common firewall vendors available, and we also support APIs to automate this process. I'm going to cancel out of this for now. Now let's take a look at the cloud storage provider once more, Mega, and see how unsanctioning an application will automatically prevent users from accessing the app when Defender ATP has been integrated with MCAS. I'm filtering on unsanctioned, and I just want to confirm that the tag unsanctioned is applied to the application Mega. You can see it is here. Let's pop into another demo and see the end user experience when Defender ATP is integrated with Cloud App Security. I'm now logged into my Windows 10 device, which is running Defender ATP, and I'm going to bring up my browser and attempt to navigate to the cloud storage provider Mega. As you can see, by unsanctioning the application in MCAS, we prevented the user from accessing an application which has not been approved by your organization. Now that I've shown you how to manually tag an application, let's take a look at creating a policy to automate this process. I'll create an app discovery policy. To do this, I will select one of our built-in templates. I'll navigate to the top, and let's use the new risky app and apply it. We will go ahead and give the policy a name. The policy template is a great framework, but I want to include an additional filter. I'm selecting the compliance risk factor, and I'm interested in identifying apps which do not meet HIPAA regulations. So we'll select that, and we'll ensure this is set to equal to false. In addition, we can tune the policy further, which I will do by removing the number of users, because I'm only interested in the daily traffic. But before I proceed, I want to make sure that my filter parameters are working as expected. And here you can see all the apps which have a risk score of 5 or lower, and I will select an app and check if it meets HIPAA requirements, which it did not. I'm happy with this filter. Now I'll save it. Next, we can apply the governance action to unsanction any app which meets this criteria. I'll choose that and click Create. Now that we've seen how to manage shadow IT with cloud discovery, let's talk about how Cloud App Security enables you to identify high-risk use and cloud security issues, detect abnormal user behavior, and prevent cloud-native threats. With Cloud App Security, you will gain visibility into user and admin activities and define policies to automatically alert when suspicious behavior or specific activities that you consider risky are detected. Draw from the vast amount of Microsoft threat intelligence and security research data to help ensure that your sanctioned applications have all the security controls you need in place and help you maintain control. Today, organizations are storing some of their most sensitive resources in the cloud. As a result, attackers are using sophisticated techniques and attack patterns. To combat this, Microsoft has dedicated research teams that are constantly monitoring the evolving threat landscape. And over the last few years, we're seeing that many sophisticated attacks are now cloud only, targeting identities, resources, and data in the cloud. Cloud App Security contains powerful detection capabilities across the different stages of an attack, from ransomware to malicious insiders. Our out of the box and user defined detections provide the activities and alerts to recognize a threat or compromise. This is achievable with our machine learning and advanced user and entity behavioral analytics, otherwise known as UEBA, which analyzes how your users use your applications to build a baseline for activities in your organization. Through various indicators of compromise, Cloud App Security can detect malicious OAuth applications, infrequent and impossible travel, ransomware activities, and unusual administrative activities, just to name a few. Our detections are use case driven to alert on specific security scenarios. So now, let's pop into a demo and take a closer look at how to perform an investigation in Cloud App Security. I'm now logged back into the Cloud App Security portal, and I'm reviewing the dashboard, which shows aggregated information that helps you better understand your organization's cloud security status. All the alerts that Cloud App Security generates are in the alerts tile, as well as the users with the top investigation priority score are listed based on factors such as the severity of the alerts and their impact to the organization. The two tiles provide a great starting point to begin your investigation. So let's take a look at our top user, Jeff Leatherman. Right away, we can see that the alerts and risky activities which have contributed to the overall score. We can also compare Jeff's score to the rest of the organization and see the trend over the last 2 weeks. In addition, the user page provides a timeline of events and the overall threat to the organization, which includes information from Azure Active Directory's identity protection and the lateral movement paths detected in Azure Advanced Threat Protection. This provides us a holistic view of events, which may provide enough indicators to make an informed decision. So let's follow the trail and get additional information about some of these alerts. I've clicked on the suspicious inbox manipulation rule, and the description gives us further information about the rule name and the actions. Here, we can see that the rule is designed to conceal by moving messages to the deleted items folder. We can also see the IP address, the location, device types, as well as other attributes associated with this activity. This by itself is pretty compelling information, but I want to build further context before taking an action. Let's review all the alerts for this user and build a timeline. We can now see that Jeff has accessed box from an infrequent country, rarely or never seen in my organization. This is immediately followed by an impossible travel. We can see too that the user has performed a logon activity from Israel to Russia and the US to Russia within the same time frame, which is clearly impossible. Returning to the alerts, we also notice that a mass download occurred, which could be an indication of a data exfiltration attempt. And with our integration with Azure ATP, we can see that Jeff enumerated accounts in Active Directory. I feel strongly now that this activity is suspicious, and I'm prepared to take an action, like suspending the user and resetting the password. Now that I've shown you how to investigate alerts, let's take a look at creating a custom activity policy. In my policy, I want to alert whenever a service account fails a login. This could be an indication of just a simple misconfiguration, but it could also be a brute force attempt for a sensitive account. But before we jump into the policy, let me show you how to import a group which contains my service account. We'll do this by navigating to the top settings cog in the top right and selecting user group under data enrichment. I've already imported the group, service account group, and you can see it contains one member. This group was imported from Azure Active Directory, and Cloud App Security will continually synchronize this group every hour to ensure it remains updated. Perfect. Now, let's create a new activity policy. We'll skip applying a template this time, but let's go ahead and give it a name, and let's change the severity to high. I'm interested in seeing every activity which matches the filter. I'll choose the activity type, which equals failed logon. And you'll also notice that this has selected several hundred failed logon events, and this is due to the fact we have connected many applications to Cloud App Security. In addition, we also need to include the user group that we imported earlier. So I'll select the user from the group, and I'll identify my group and select it. Lastly, I'm going to ensure that we create an alert so this can be investigated further. But it's also worth noting that we could build in some Power Automate playbooks to extend our automation capabilities further. Great. Let's go ahead and click Create. And now that we have the policy, let's take a look at what happens when the service account fails a login. I've initiated a failed logon for the service account TAC2 for NVA on my test machine. From the dashboard, we can see we've also generated the alert for the policy we just created. Let's go ahead and click on this and take a deeper dive. In the description, we can see the account which triggered the policy, and below, we can investigate additional metadata about the event. We can see the user group which triggered this alert. We can see the location, the device types, and the corresponding IP address to see if this information is expected and associated with the service account. If it is not, this could indicate a malicious attempt to compromise the account. If it is, then obviously this is a potential misconfiguration. This concludes the demo, and next, Caroline Lee will show us how to protect our files in the cloud using Azure Information Protection, and she's also going to walk us through Cloud App Security's real-time monitoring and session controls.
Awesome. Thanks, John. So now I'm going to go into our last two sections, which will be about information protection and real-time information protection. So let's get right into it. The first step in protecting your files and data in the cloud is to understand what your data exposure is. MCAS does integrate with a number of third-party applications using our API-based app connectors. Some of these third-party apps include G Suite, Dropbox, Box, and etc. By connecting your apps, you gain much more visibility into the sharing level, what's being stored on those apps, and who are the collaborators. After this, it's important to govern this data using our data loss prevention policies. MCAS does directly integrate with Azure Information Protection, meaning we can use the sensitivity labels within our file policies, in addition to being able to automatically protect and encrypt this data. And then lastly, it's important to create policies that cater to your specific needs and trigger automatic governance actions, such as making a file private or removing an external collaborator. So now let's walk through a typical use case. Let's say you have an internal employee who uploads a sensitive file to their personal OneDrive. Because of the file policy you created in MCAS, a classification label gets automatically applied to protect this file. Now, what happens when a user tries to share this file with an external party, possibly even a competitor? That external user won't be able to access that file due to the classification label that was applied. And then lastly, an admin will receive an alert that this happened and can further investigate. So now let's talk about the file and data control architecture. Within Cloud App Security, there are two scans that happen. The first scan is what we call the at-rest scan. So this one is ongoing and will scan your files from oldest to newest. The second scan is what we call the near real-time scan. So the moment a file has been changed or added, it will be scanned through this queue. It'll go through the content scan engine or the DLP engine or a third party, depending on what you choose. After your files have been scanned, we'll be able to gather information such as what the files are, who are the external collaborators and users, and then take the appropriate governance actions when needed. If there is a policy match, you'll see these alerts within MCAS. You could also get a text or email notification, and we can also send these alerts to your SIM. So now let's get into a demo. All right, so the first thing that you're going to want to do is navigate to Cloud App Security and go to your settings. Within your settings, you're going to want to click on Files underneath Information Protection and check off Enable File Monitoring. This will allow Cloud App Security to see all of the files currently living within your SaaS applications. Next, you're going to want to click on Azure Information Protection. There are two checkboxes here. One, to automatically scan for new files that have AIP labels, and two, to only scan files with AIP labels within this specific tenant. So now let's take a look at our Files page. So the view that we see here are all of the files across our SaaS applications. So we have Microsoft SharePoint, AWS, Box, and the rest of the connected apps. At the top here, you can alter this view by the different filters. So maybe by access level. Let's look at files that are currently being publicly accessed. So you can see that there are 87 files that meet this criteria. Some of these are highlighted in pink because they've already matched to a file policy we have in place. Let's take a look at Project X. We can see that it has 6 collaborators. Let's click into that. So it has a publicly shared link, some external collaborators, and internal ones as well. Maybe I don't want this file to be publicly shared. I can actually take immediate action from this view. So if we click on the 3 dots, we can see that there are a bunch of governance actions that we can take, such as applying an AIP label, putting into user quarantine, or simply just making it private. But instead of manually going through all of these files and deciding the actions, we can actually create a new policy from search to do this for us. So maybe I'm a healthcare company and I want to protect any files that contain social security numbers. So I'm going to create one for this. The access level will stay the same, so anything that's being publicly accessed. And then maybe I want to apply this to only a couple of applications. So let's choose Box, Dropbox, and then SharePoint Online. Underneath the inspection method, I'm going to choose the data classification service. This is primarily where majority of our investments are going, so we recommend users to choose this inspection method. Within the inspection type, I'm going to choose sensitive information types. So you can see that we have over 100 sensitive information types that we can use. The way that I like to describe these are the most common patterns of data that we see today. And it is global. So we have Argentina National Identity Number, we have the Brazil CPF number, and other markers such as these. I'm going to type in Social Security number. I'm just going to check off all of these. One other thing I do want to mention is that if you don't see a sensitive information type that you can use within your policy, you can actually create your own custom one on protection.office.com. So for now, I'm just going to choose these. There are some advanced settings you can take as well. So right now, this policy will match on any file that contains at least one social security number. Depending on what sector you're in, you may want to bump this up. That way you're not bombarded with alerts. Next, I'm going to create an alert for each matching file. You could choose to have it sent as an email or text, but you can also send alerts to Power Automate. So you can create your own custom flows on Power Automate and use them within your policies, such as automatically opening up a Jira ticket for each alert. But for now, I'm just going to keep it on this current selection. And then here we have the governance actions. So depending on the applications you've connected, you'll have a couple of governance actions here. So for Box, for example, if this policy matches, then maybe I want to just remove the direct shared link. I also have the option to apply an AIP label here. So maybe I'll do that as well. The actions will vary across application. So you can see for Salesforce, we're allowed these 2 actions, but for Box, we have way more. And then maybe for Microsoft SharePoint Online, I'll remove a collaborator. So I've actually already created this policy, so I'm not going to save this one, but I want to show you what it looks like when a file matches. So let's navigate back to Files. I'm going to search for the policy that I had previously created. And we can see that there are 5 files that match this. Some of these have this tag next to it. This means that this file has an AIP label applied. If we click into this and click into the policies, for our specific policy, we can see the last 4 characters for each social security number and the first and last name for each user. If we click into the actual policy, we can also see all the files that match specifically to this policy. If we had quarantined any files, you would see it in this tab here. And if we had authorized anything here, you would also see it in the history. Now, the last piece that I want to show is the data sharing overview. So we can see a list of all the applications we've connected to, the number of files, and where they're being shared. So for example, for Box, we have 59 files that are currently being publicly shared. It may be a good idea to investigate why there are so many. So that's the end of the information protection demo. Okay, so now let's get into the last section for today, which will be around our real-time information protection feature. So protecting your data anywhere in the cloud in real time. MCAS allows us to restrict certain actions based on conditions. These conditions could be based on the user, location, device, and application, and will essentially determine how risky a session is based on those conditions and take the controls we need. So, for example, let's say you have a user who's working from home, logging in from an unmanaged device, and is trying to access the company SharePoint. Maybe it will allow the user to view the documents that they need, but not allow them to download any sensitive information. We can use MCAS to take these types of granular controls. Some other ones are blocking download with an AIP label, block print, copy cut, and some data infiltration ones as well. So being able to block upload. One thing about this feature is that it requires applications to be configured with single sign-on using an identity provider. MCAS does support any custom IDP that can be configured through the MCAS console, such as Okta and Ping. But if you're already using Azure Active Directory, then the deployment is much more streamlined because this feature is actually built on top of Azure AD's conditional access tool. So now let's walk through a typical use case. Let's say you have a user who's trying to access Box. We can see that they're authenticating through Microsoft Azure AD, and if their session seems low risk, then we'll allow them to directly go to Box. But if the session seems risky, we're going to proxy them through our MCAS session server and check a couple more conditions. We'll check to see if the device is compliant or domain joined, the user behavior, so if it's deviating from their normal behavior, the user organization, so maybe the user is a partner versus an employee, and the location, so maybe they're logging in from their home Wi Fi versus their corporate one. Depending on these conditions, we'll enforce the relevant policies we need with real time control. So if the user is logging in from an unmanaged device, maybe we want to protect those downloads using an AIP label. Or if they're logging in from an unfamiliar location, maybe we'll have them go through multi factor authentication. All right, so let's get into the demo. I'm going to be demoing from two perspectives today. The first perspective is going to be what does this feature look like as an end user? And the second will be from the admin perspective. So how do I configure the policies I need in order to enforce real-time control? All right, so you can see here I'm logged in as Sylvia from my unmanaged device. Let's see what happens when I click on Box and try to download a sensitive document. So I'll log in as part of Contoso. So I'm authenticating through Azure Active Directory. And one thing I do want to point out here is this URL addition, us2.cas.ms. This means that our session is currently being proxied by Cloud App Security. So let's take a look at some of the documents here. I see this one called Secret Ingredients. What happens when I try to download this document? So Cloud App Security blocked this download in real time. We also get a tombstone file containing the block text for this. The second scenario I want to show you is for Workplace by Facebook. So you can see that I'm talking to Jeff, again logged in as Sylvia, and I said, hey Jeff, are you able to log into the company portal? Can you try my creds? They're not working. So let's see what happens when I try to send him my password. Again, this action was blocked by Microsoft Cloud App Security. So now that we've seen what happens from the end user perspective, let's see how we would configure this from the admin side. So I'm going to go to Azure Active Directory, and I've already navigated to the conditional access policies. I have a policy here that I'm calling demo. I've scoped it to all users, and now I'm going to choose the cloud applications. So I'm going to choose Box, and I'm going to choose Workplace by Facebook. Next, the most critical step in this process is underneath access controls. You want to click on Session and check off Use Conditional Access App Control. Within this dropdown, use Custom Policy. This will allow us to further scope down those granular controls within Cloud App Security. And then, of course, it's important to enable this policy. I've already created this one, so I'm not going to create it here. Instead, I'm going to navigate over back to Cloud App Security and show you how we would configure the session policies. So I'm going to create a session policy. I'll call this one Block Sensitive Download. The session control type is Control File Download with Inspection. So it's already scoped down this to unmanaged devices, and I'm going to choose my application as Box. And the inspection method I'm going to choose is Data Classification Service. Under the sensitive information type, maybe I want to block sensitive files that contain credit card information. So I'll choose this one, and then I'll unmask the last 4 characters of a match. And I'm going to protect this file. So I'll protect this file with an AIP label, maybe highly confidential. And then I'll also create an alert for this. So that's how you would configure the first session policy. Now let's take a look at how we would configure the second policy for that Workplace by Facebook use case. So maybe I'll call this one Block Sending of Messages. And here I'm going to choose Block Activities. So the device stays the same, unmanaged. The app, I'm going to choose Workplace by Facebook. And the activity type will be Send. There we go, Send item. And then I'm going to use Content Inspection. Within the custom expression, I'm going to put in password. And then the action will remain as block. You could add your own customized block message here as well, such as, please contact IT. So that's how you would configure the second use case. Next, I want to show you what this looks like within the MCAS activity log. So if we navigate to the activity log, we can see a series of events here from Sylvia. First, that she navigated to Box and was redirected through the reverse proxy through single sign-on. She tried to download a file, the secret ingredients, and she was blocked. Next, you can see the same action she tried to do within Workplace by Facebook. This action was also blocked. And then lastly, in order to see all of the conditional access control applications, you're going to want to navigate over to Investigate, click on Connected Apps, and click on Conditional Access Control Applications. This is where you'll see all the apps that are currently configured to be part of Conditional Access App Control. And there is a plus sign here where you'd be able to configure your SAML applications with the third-party IDP. All right, so lastly, let's talk about a couple of resources and where you can find us. Check out our best practices document. We have an MCAS POC. We record all of our different webinars on MCAS recordings, and we have a bunch of interactive guides that you can check out if you're first getting started with Cloud App Security. And lastly, if you have any questions, feel free to post on our tech community. Thank you so much for joining us, and tune in next time.